Namaskar everyone. Today we will try to see working of operational amplifier. A typical operational amplifier has these terminals. So first terminal is non-inverting terminal. Then this terminal is called inverting terminal and output is obtained at this terminal. Positive voltage supply is applied at this terminal and negative voltage supply is applied at this terminal. Now let us see the working of operational amplifier LM741 on Tinkercad, and there we will also understand why this terminal is called inverting terminal and why this one is called non-inverting terminal. So here we are on Tinkercad. Now let us find a breadboard here first of all. So we have a breadboard. Now let us find the LM741 amplifier. Here is the LM74 amplifier. We will bring two batteries. So one battery is here, another battery is here. We'll bring one 1.5 volt battery here and another 1.5 volt battery here. Right? Now, this is a terminal for inverting input, non-inverting input. This is for negative power. So connect the supplies first of all. Okay. So this is non-inverting input. We will connect it this way. And this is the inverting input. Now the whole circuit is complete, and I think yes, here we have to connect it to positive supply. Now let us bring one voltmeter. And try to measure the voltage at the output. Now let us run the simulation. So we are getting 0 volts at the output. Why is that happening? Because we have connected 1.5 volts to the non-inverting terminal of the operational amplifier and 1.5 volt also on the non on the inverting terminal of the amplifier. So the difference of the two is 0. So at output, 0 multiplied by some amplification factor would give 0. Now let us do one thing, is that remove this input which is we are getting at the non-inverting terminal, and instead of that let us connect it to ground. Now let us see what is the output that we get. Now we are getting the output as 9 volts. Now this is important to observe here is our input was 1.5 volts minus 0, that becomes 1.5 volt, and the output at the end is 9 volt. Now important to note here is the amplification factor of an op amp is very high. So when we give 1.5 volt at the input, it multiplies it by the very high gain and it gets saturated very soon. The saturation of the amplifier is given by the supply voltage. Supply voltage in this case is 9 volt. Now let us remove this input now, and now we are giving input at the inverting terminal. Now let us try to see. One moment. This we will connect to ground. We have given 1.5 volts here. So the output now we are getting minus 9 volt. So this demonstrates why we call this terminal as inverting terminal and why this terminal is called non-inverting terminal. When we apply some voltage to a inverting terminal, output gets multiplied by negative. And when we apply some voltage at non-inverting terminal, output does not get multiplied by some negative factor. Now let us bring one potentiometer and try to see what happens if we give very small voltage at the input. So I will remove this upper battery so that space gets created for potentiometer. So now I will bring one potentiometer. Here is a potentiometer. I have connected its one end to the non-inverting terminal, this end to the battery. Right. Now, and this end I will connect to ground. Now let us see what happens. If I run the simulation, I'm getting 599 volts at the output. And as I increase the voltage at the input, immediately it becomes 9 volt. Just see. Immediately it becomes 9 volt. Initially it was 599 volts, millivolts. Sorry, initially it was 599 millivolt. Then as I am increasing the input voltage, output voltage is immediately increasing 9 volt. Now let us see how much is the input voltage that I am giving. So another voltmeter. So this voltmeter is here to measure the input voltage. So I will start now. When the input voltage is 1.5 volt, output is 9. When I reduce the input voltage 1.27 volts, again output is 9 volt. When I reduce it to 960 millivolt, then again output is 9 volts. And when I'm making it very small to 236 millivolt, still the output is 9 volt. So if I make it, it's around very less now, very less, close to zero is the input voltage, and output is 599 millivolt. And for 29 millivolt, the output voltage is 9 volts. So just see how much is the amplification gain in an operational amplifier. And the output voltage, as we have discussed earlier, is limited by the supply voltage. In this particular example, the supply voltage is 9 volts.